Hi friends, in this video we are going to look at a newly appeared problem, problem 2958, length of longest subarray with at most key frequency. Our strategy for addressing this problem will be the standard two-pointer sliding window method, but here our goal or our main purpose is to explain why we can use two-pointer sliding window method here. So first, we are going to digest the requirement of this problem, and then we look at coding. So first, let's look at the digest. So we are given an integer array nums and another integer key. So we want to find the length of the longest good subarray of nums. So here by good, we mean that if the frequency of each element in the array is less than or equal to the given integer key. So it also emphasizes that subarray is a contiguous piece of the original array, right? So here we have three examples. In the first example, the output is 6. For example, you can look at the first 6 elements. So in this subarray, so each element appears twice, right? So, but this good subarray is not unique, but you see this one. So it also has length 6, and each element appears twice. So in example 2, the k is 1, so we can have 1, 2, right? So 1, 2 is in this subarray, each element appears exactly once, right? You can see 2, 1 here, right? It's also good. So in the third example, the k is 4, so we should return 4 because this list contains the unique values 5, right? So with that said, let's also look at the constraints. First, the length of this list is bounded above by 10 to the power 5. So in other words, if you think of term complexity, so typically, for example, n squared term complexity will not pass all the cases. So here n is the length of these nums. So also k is bounded below by 1 and bounded above by the length of this list. So this is for sure a consistency assumption. So with that said, we are ready to look at the analysis. First, I'm going to see the strategy will be two-pointer sliding window. Right? So here we want to explain why can we use this trick here. Actually, we have a playlist in our channel which contains tens of such problems, so you are welcome to check out. So now let's come back to the problem here. So the thought is actually very straightforward. So the idea is that, so for a good subarray, right? It for sure it has a starting index, right, and end index. So I'm going to call this the start index L and the end index R, right? So then because of this trivial observation, so we just need to, for each left index L, so we want to locate the largest possible R. The largest in the sense that the elements in between L and R, both inclusive, are such that each element in this range has a frequency less than or equal than k. In other words, largest, so look at the largest in such that, let's see, such that the nums L and R is good, right? So as long as we can find for each left index L the corresponding R, then when we compute the length will be nothing but R minus L plus 1. And then we just pick the largest one, right? So here, why we can use this trick is due to the monotonicity. This is very important. For example, you have a index, say L1, and then you located its corresponding largest right index is R1. And then you have an increment L1, say by 1 or by 2 by something. So you have L2, and then you locate the corresponding right index. Then here we have this order relation. So if L1 is less than L2, and then we have R1 will be less than or equal to L2, right? Because L2 is larger, so we didn't consider the elements before L2, right? So which makes us leaves us room to push R further to the right. So this will be the whole logic for this problem. So with this, basically is some abstract discussion. But now let's first look at the coding, and then later we can do a walkthrough. So for the coding, actually it's rather straightforward. First, I'm going to initialize a result variable that is 0. But for this problem, because the result will be at least 1, because k is greater than or equal to 1, and the length of this list is also bounded by 1. So you can initialize by 1, but 0 will be fine, right? So here also let's get the length of this nums list. This is just for convenience. And then I'm going to initialize a window. So this window will be a dictionary. And also we want to make a maximum frequency to track the process. And then we can do the 2-pointer sliding window. I'm going to initialize R to be 0, because the starting for the left index will also be 0. Then for L in range M, right? Then we're going to see if we can push R to the right? So basically, while R is less than N, and max frequency will be less than or equal to K, right? So now the current number we are looking at is nums R. So if we include this one in the window, so the corresponding frequency will be incremented by 1. So this is a new frequency. So new frequency should be a window. I'm going to use get method because nums R may not be in the dictionary yet. So if it's not in, we're going to set its default value to be 0. Then we'll increment by 1. So now look at that. With this code, we haven't add nums R to the window yet, right? Because we need to check if new frequency is still less than or equal to K. We can do this operation, right? Basically window nums R, so we can increment this frequency. Correspondingly, we set it to be the new frequency. And then we can update the max frequency. The max frequency will be the max between the previous one and the current new frequency, right? So this will be the main logic. Then after this, we can push R, increment R, aiming to push it further to the right. Otherwise, so if you add this R, this current element will cause the maximum frequency to be larger. Then in this case, we need to just break, right? So once we exit this while loop, so we have two possibilities. Either R is N, or the max frequency will be greater than K, right? So with that done, now let's update the result. So each time we update the result will be max of the previous stage and R minus 1, because the current R will be such that this condition is validated, right? So we should, this is the end, right? Then minus L plus 1, right? So overall it's R minus L. So once we've done this, so we can, we need to prepare for the next round. We need to exclude the current L. So what we are going to do is window nums L is decremented by 1. And let's do further. If window nums L is 0, I just delete that. So that's basically the logic for each round. So now we just need to return the result. So this actually forms a solution format to this problem. So before we make any comments, let's first do a test. Yeah, it passes one example. Now let's look at the generic case. yeah, it passes all the cases. So now let's print out some information so that we can have a better understanding. So now, for now, let's see, we can see print. So the window enter in, so within round L, right? The window will be the current one, and then we'll also print out, say, L is L, and R is the corresponding R, right? So afterwards, let's also print out the window information, because after round L, so we actually exclude the current nums I. Now let's do it. Yeah, so this is for example 3, right? So now let's look at this one. Right. So you can take the corresponding left index, and R-1 will be corresponding right index, right? So within this one, you get, this is the dictionary. Then afterwards, you know, the 1 count is decremented by 1. So with that said, basically that's about it for this problem. So if you have difficulty in understanding the coding part, you're welcome to try and walk through the code using some examples. Or you can check out the corresponding playlist in my channel for further information. So with that said, thank you.